All right, guys, so today we're going to look at factoring, okay? Specifically, in just a moment, we're going to look at how to factor what's called a simple ABC, okay? This is just where we have three terms. So here we have this term, and this term. We have three separate terms, just like in these problems below, and we'll look at how to factor those, okay? Since this is an intro to Algebra 2, you are actually going to hear your Algebra 2 teacher talk about factoring a lot. So I teach Algebra 2 as well. When I teach Algebra 2, I tell my students that factoring is really one of the most important things you have to learn in all of Algebra 2. It shows up in just about almost every unit that you have going forward in Algebra 2. So if you can learn how to factor now and factor successfully, it's going to be a huge benefit to you when you get to Algebra 2 and you're like, oh, I already know how to do this, like done, easy, okay? So first I want to just go over some quick vocabulary so we understand what we're talking about, and then we'll get into some actual problems. So whenever you hear someone say the word factor, okay, or factors, more than one of these. Factors are just numbers. Okay, that's all they are. Factors are numbers that you can multiply together, numbers you can multiply together to get another number. So that might sound a little weird, but really it's as simple as this. Check this out. 2 and 3 are factors, okay? They're numbers that we can multiply together. You see they're being multiplied to get another number, which is 6. So we would say that 2 and 3 are factors of 6. Okay? So hopefully you practiced doing this before, like quite a bit in elementary school and stuff like that, where you would take some number and then find its factors, okay? So like if we look at the number 18, what would be some factors of 18? What are two numbers that multiply together to make 18? Maybe you're thinking of a couple different pairs of numbers, but the first ones that jump into my head are 2 and 9, right? If I take 2 times 9, that multiplies it to make 18. And so if you're definitely going to have an advantage if you know your times tables, right? Like if you know your multiplication tables. Because for me, off the top of my head, I just knew that 2 times 9 makes 18. So if you're in that place where you know your multiplication tables, it's going to be really, really helpful going forward for these problems. If you struggle a little bit with your multiplication tables, I have some ways to kind of work around that, and I'll definitely be going slower through these, just in case you don't know your multiplication tables, but if you do, there's definitely some places where you can kind of fast forward a little bit as I go through things a little bit slower in case you don't know your times tables, okay? So both 2 and 9, those would be factors of 18, okay? So check this out. It's going to be a little weird, but something as crazy as this is really just a number, okay? Because if I took numbers and plugged them in for x and x, like let's say I plugged in the number 1, right? 1 squared plus 4 times 1 plus 3, well, I could simplify that and I'm going to end up with one number, okay? So even though this has x's in it, okay, this is representing a number. It's really weird. This is representing just one number. So that means this has factors, okay? So here are the factors, right? Like I could take this x plus 3, this is a factor, and multiply that by x plus 1, and I get this as my answer, okay? So these would be two things that can multiply. Again, there's multiplication happening here. These can multiply to make this. So these types of problems, and this is in the form of a simple ABC, these are what we're really going to focus on factoring right now, okay? And then, if you've heard the word distributing, right? Distributing is just a way to say that we are multiplying something So for example, like if we see this 2 that's outside of this set of parentheses, what is your like gut reaction with what you're supposed to do with that, right? Hopefully, your teachers before, like in Algebra 1, kind of trained you to look at that and think, all right, I need to distribute this. I need to take this 2 and multiply it to the y and multiply it to the 3. Okay, so hopefully that looks a little familiar. So you would multiply, we're distributing, 2 times y, that gives me 2y, hey, and then 2 times 3 gives me 6. I just distribute this. Factoring is actually distributing, but in reverse. So now I'm going to start with something like this, and I will factor it so that it looks like this. Okay, so how do we go about doing this? How do we factor something? Well, crazy enough, hey, distributing is multiplying, right? So what's the opposite of multiplying? Dividing. So one way we can think about factoring, to make it a little bit simpler, factoring is just division, okay? Where distributing is multiplication. So that's some terms, that's the idea of factoring, that's what we're going to be doing. Let's jump into some problems now. So we're going to actually skip all of these where we're worrying about the GCF. Your teacher in Algebra 2 will definitely go over these, but for the sake of time, we have to skip these. We're going to move on to simple ABCs, okay? All right, so here's how this is going to work. We have 3 terms, once again. And in these 3 terms, all of these 3 letters, so A, B, and C, are going to represent numbers. And so we can clearly see in each of these examples, here, C is -36, B is -5, please include the sign in front of it, and then A, what is A? I don't have a number there. Well, since this is a simple ABC, the nice thing is that A is always going to be 1. So that's what we see in for A, in the very, very, very front of all of these problems is the invisible 1. So you're not going to see it written, but we understand that there is an invisible 1 that is there in front of all of these. Okay. Here we go. How do we start a problem like this? Very first thing you do, so step 1, is you're going to take C and kind of pull them off to the side and work with them a little bit. So 16, positive 16, I'll include the sign. I'm going to pull them off to the side, and now I need to think of pairs of numbers that multiply to make 16. So if you know your times tables, this should be pretty nice and fast, right? Like you can think of a couple different pairs of numbers that multiply to make 16. If you don't know your multiplication tables very well, here is the strategy that you would go about. The very first pair that you're always going to put is 1 times whatever number you're working with. So 1 times 16. You can test that in your calculator. I highly, highly encourage you to have a calculator in your hand while you're watching this video so you can not only just listen to me, but like actually plug it into the calculator and see for yourself that what I'm saying is true. So right, like if we take 1 times 16, that multiplies to make 16. Okay, these would be factors. Okay, 2 numbers that are factors. Now, what I'm going to work on next is, since I already know that 1 works, I'm going to go up to the next number. So 1, and I'll test out 2, and then 3, and then 4, and I'll keep testing numbers. And the way that I'm testing is I'm dividing. Okay? So next I'll test out 2. So I'm going to take 16 and divide that by 2. So in the calculator, I'm plugging that in. 16 divided by 2. And I get 8. So that is telling me that if I take 2 and multiply it by 8, I'm going to get 16. Okay, and you can check that in the calculator right now. Don't just believe me. Actually, like, try this out and see. 2 times 8 makes 16, right? All right, wonderful. I found a pair. Then I'm going to move on to 3. Okay, 16 divided by 3. What do I get? Oh gosh, okay, so in my calculator, I'm getting 5.33333 repeating on, and even though it stops in your calculator, this actually goes on forever. Your calculator just can't hold all of the 3's that go on forever. This is something we do not want to see. So remember how when we divided 16 by 2, we got this clean 8. There was no decimals after it. That's exactly what we want to see for a factor. So since when I just divided this by 3 right now, and I got a number, I got 5, with a bunch of decimals after, that is not going to work for a factor. For us, for our sake, we don't want factors that have decimals. No decimals, not going to work. So 3 is not going to be a factor of 16. 3 is not a factor of 16. So 3 didn't work. I'll move on to the next number, 4. So let's test that out. So 16 divided by 4. And there, I got a clean number. I got the number 4 out. Okay, so that means 4 times 4 gives me 16. Okay, now the cool thing about this, oh gosh, that was weird, my voice. Okay, the cool thing about this is that the numbers on this side go up, right? 1, 2, 4, they're going up. I'm counting up. And then these numbers always go down. 16, 8, 4, those are going down. And the cool thing is, as these numbers go up, as these numbers go down, they should meet together right in the middle, okay? Like, see how this is 4 and this is 4, they're both the same number, right? That's my clue to stop. I'm done. I don't need to test out 5 or 6 or 7 or 8. I'm done if I see the same number on the other side, okay? Or if I get really, really close to that number, maybe I'll be like at 5 and 6, or maybe like 6 and 8 and 1 or 2 numbers away. We'll look at problems like that in just a second. But since I got the same number here and here, that's my cue to stop. Those are all the factors. Cool. So now that I have all of my pairs here, this is the next thing I'm going to do. Okay, I need to figure out the pair, find the pair, because these are all pairs. Pairs come in 2. Find the pair that adds, really crucial, that adds to make B, okay? Or the number, right? The number that's in place for B. So in this problem, the number that's in place for B is positive 8. So I'm going to go through these pairs of numbers and add them together and see which one of these make 8. So 1 plus 16, that makes 17. Not going to work. 2 plus 8, that makes 10. Not going to work. 4 plus 4 makes 8. Perfect. That's what I'm looking for. That is my answer there. Okay? So here, I pretty much am almost done with this simple ABC. All that I need to do is I'm going to actually factor this always into 2 binomials. Okay? Binomials, bi means 2. That prefix bi means 2. That means there's going to be 2 terms inside of each of the parentheses. I have x and 3. Those are my 2 terms. X and 1. Okay? So we'll get something that looks just like this. So 2 sets of parentheses. They'll both begin with x. So x and x. And then the second term are these numbers that I just found. And I want to include the signs with them too. They're always going to have a plus or subtraction sign in between the x. So since these are both positive 4, I'll put plus 4 and plus 4. Done. That is my answer. So I factored x squared plus 8x plus 16 into this binomial. All right, or these 2 binomials, sorry. Now, here's one quick way. I'll only do this for this problem, but here is actually a way to check your answer to know if you actually did this correctly, okay? Hey, so remember how I said if we factor something, the opposite of that is distributing. So if I was to distribute everything that I just did, if I was to multiply it all out, and I get what I started with, I did all of this correctly. All right, so let's do this. I'm going to do some really fun distributing right now. So I will take x and I will distribute that, or I'm multiplying it. Here we go. So x times x gives me x squared. And then I multiply it again to the next term. So x times 4 gives me positive 4x. So now that I took x and I distributed that to both terms, now I'm going to take 4 and distribute that to both terms as well. So 4 times x gives me 4x. And then 4 times 4, positive 16. Let's go ahead and combine our like terms, and it looks like these are the only like terms. So I get x squared plus 8x, so just add those together, 8x plus 16. Perfect, that's what I started with. So I did my factoring correctly, okay? Because I checked it by multiplying it all out, and I got what I started with originally, okay? All right, so there's a full flesh through example. Let's try another one. So this one is going to be a little tiny bit trickier because now we're going to be throwing in some negatives, and we're going to have to pay close attention to the pairs that we're finding and the signs, whether they're positive or negative, when we're doing these problems now. Okay. So once again, do you remember how I started this? What was the very first step to this problem? Okay, so the first step is I'm going to take C, so whatever number is in place for C, and I'm going to pull them off to the side and find some factors for them. So in this case, that would be negative 36. Please include the sign in front of that. Okay, it's negative 36. So right now, as I'm about to find pairs of numbers that multiply to make negative 36, since this is negative, and you're only going to do this with negative numbers, I'm actually going to ignore the negative just for right now, and then I'll think about it later, but at first, just completely pretend the negative is not there, okay? So let's just worry about positive 36, and then we'll come back in a second and fix this negative, okay? So, if you recall, what's the very first pair of numbers that you're always going to put? 1 times the number itself, 36. Again, I know, don't worry about the negative, okay? We're just going to think about this as positive, and then we'll come back in with a negative in just a second. So 1 and 36. Okay, so we have that. Then I'm going to start counting up here. So let's try 2, 3, 4, 5, and see if any of those numbers work when we divide them by 36. So next is 2. So let's see, if I take 36 and I divide that by 2, I get 18. Perfect, that came out nice and clean. There's no decimals, so I definitely know that that's a factor. So 2 times 18 gives me positive 36. All right, next number. So let's try 3. So 36 divided by 3, and I get 12. Came out cleanly. That looks good. Now let's try 4. So 36 divided by 4. Came out cleanly again. Well, there's a lot of pairs of factors for 36. So 4 and 9. Let's try 5 now. So 36 divided by 5. Let's see, 36 divided by 5. Ooh, okay, I got 7.2. Not going to work. That has a decimal, okay? So 5 is not a factor of 36. So let's skip 5 and go on to 6. So 36 divided by 6. Aha, there we go. It gave me 6. So I don't know about you, but this is my cue to stop. I'm done. I don't have to test out 7, 8, or 9, or 10 because I got the same number on the other side. As these ones were going up, these ones went down, and they are meeting right in the middle there and there at 6 and 6. Cool. Okay, so now that I found all of my pairs, we need to find the pairs that are going to add to make B. Again, remember that's what we're doing. We have to find which pair of numbers is going to add to make negative 5. Okay, in order to figure this out, we now have to think about that negative that's in front of this 36. So check this out so we can write this down. Because C, because this was our number for C, because C is negative, okay? So we don't have to worry about it if it's positive, but if this is negative, one of the numbers in each pair is negative. Okay, well, what does that mean? Well, if I think about it like this, 1 times 36, that makes positive 36. But if one of the numbers, just one of these numbers, like let's say 1 was negative, then that's going to multiply to make negative 36, right? My problem is I don't know if this number is going to be negative or is this number going to be negative. So either one would work to multiply to make negative 36, but the way that I figure out which one is negative is because I'm also going to test to see does it add to make negative 5. So let's go ahead and do that right now. So I'm going to go through, put a negative on each of these, and go and see and test if I add them together, which one is going to make negative 5. So if we test out the first pair. So negative 1 and positive 36. Nope, that adds to make 35. That's not going to work. How about this, if I put a negative here? No, that's going to add to make negative 35. So this is not going to work at all to make negative 5. So let's move on to the next pair. Let's say if this was negative. So negative 2 and 18 makes positive 16. That's not going to work. How about if this was negative? 2 and negative 18. That's going to make negative 16, so still not going to work. And I just keep going down the list of numbers. So how about if this was negative? So negative 3 and positive 12. That makes 9. Not going to work. How about if I do it this way? That makes negative 9. Still not going to work. Okay, maybe this will be the charm here. So negative 4 and positive 9, that adds to make positive 5. Ooh, we're getting a little close. And then let's try it this way. Positive 4 and negative 9. Bingo, that's it. Positive 4 and negative 9 add to make negative 5. We've found our needle in the haystack. This is our pair of numbers. So what we just learned is that 9 has to be negative and 4 must be positive. They multiply to make negative 36. You can test that in your calculator. And they're going to add to make negative 5. Okay. All the other ones, they weren't working. They weren't adding to make negative 5. But only this pair is going to work. So that means I'll write it kind of just like this last one. I'll put 2 sets of parentheses. Notice here how there's an n instead of an x. So I will use n and n. And then for one of these, I'll put plus 4, and the other one, minus 9. Order does not matter here, so if you wanted to put minus 9 first and then plus 4, that's totally fine. You can switch these around, and the order of them does not matter, okay? So there's our answer. And if we were to distribute all of this out, and I won't test it with this one, but I encourage you to do so, multiply all of this out, and you would end up getting n squared minus 5n minus 36. We would get what we started with, okay? All right, we're going to do one final example here, okay? All right, so onus on you. What is my first step? Okay, so if I've gone through these first 2 examples, what is the very, very first thing I need to do? Okay, so I'm working with C first, so we'll take my positive 6, I'll pull them off to the side, and now I need to think of pairs of numbers that multiply to make 6. So the first pair I start with is 1 times 6. And really, I don't know, if you do know your times tables, this is the one that people forget the most. It's just the simple one, like the 1 times the number itself. So please never forget that pair. So 1 times 6 is always, or 1 times the number itself is always going to be something you'll put. All right, and then hopefully you know that like 2 and 3, 2 times 3, that's going to multiply to make 6, right? If I take 6 divided by 2, I get 3. And then if these numbers are not the same, right? 2 times 3. And before we've always been ending in the same number, right? 4 and 4, 6 and 6. But if I was going to try and divide this by 3, right? Like I would just get 2 left over. So then these start flip-flopping. And really, I don't need to write this third one here because 2 times 3 is the same thing as 3 times 2. It's just written around the other way. So I can just have that first one. I don't need to write the other one switched around, and that'll be fine. So we want each of our pairs to be unique. You shouldn't have the same thing written the other way around. Okay? Beautiful. So now that I have my 2 pairs, that's really it. Those are the only 2 pairs of numbers that multiply to make 6. I need to figure out which one of these are going to add to make -5. Okay, this is a little weird because 1 and 6, that adds to make 7, and then 2 and 3 adds to make +5, but not -5. So what's going on here? So remember, right, if I have a positive and a positive number, they multiply to make a positive. A positive and a negative multiply to make a negative. But I can also have a negative and a negative. If we remember this, negative and a negative multiply to make a positive. So what if all of these numbers were both negative instead of both being positive? So this is something we can also check for. Well, that would make -7. And let's see if they were both negative. There we go. -2. Actually, let me write this a little cleaner. -2 and -3 would both add together to make -5. Perfect. That's what we're looking for. And they multiply to make +6. So that is our answer. So we write our 2 binomials. Both of them start off with x. And then inside we'll put -2. Please include the signs, and -3. And that would be our answer.